2, 1. All right, we're solving by graphing. Now, I want us to rewind back for just a minute to linear equations. If I gave you, and I'm going to put it in standard form. If I gave you this and I asked you to find the intercepts, tell me what you, if I asked you to find the, okay, so if I asked you to find the x-intercept, you would plug in 0 for what?
For y.
For y. Do you agree with that? Does everyone in here agree with that?
Yeah.
Okay. And I would then solve it for x, and it would tell me where it crosses the x-axis, right?
Yeah.
Okay. So, do you think that this is a general statement? To find any x-intercept of any equation, can you always just plug in 0 for y?
No. Well, yeah.
Think about any graph whatsoever, or any equation when you graph it, no matter what that equation is.
Well, it could have more than one.
It could have more than one, but is it still true that every time it crosses here, y is 0?
Yeah.
Sure.
Yeah.
So any equation in the whole wide world, if you plug in 0 for y, you solve it, you're going to find the x-intercepts. Do we all agree?
Yeah.
Okay. So then does it follow, can I say that backwards? If I have a graph,
Yeah, it's literally the same thing. Oh, there's not y.
and I find these values, then I have found the values of x when y equals 0. Do you agree with that?
Yes.
It's just the backwards of what we said the first time.
Yeah.
So that's what we're going to be doing. You're going to have an equation, let's say x squared minus x minus 6, right?
Yeah.
And I'm going to say, okay, here's your equation. Solve it for x.
Okay.
Well, what have I really done? I've just replaced y with 0. So if I solve this for x, what I'm doing is I'm finding the x-intercepts. And we're going to do this on our calculator. Okay? We're going to do it on our calculator. We're going to solve by graphing. We're going to find the places where it crosses the x-axis, and it's going to tell us the solutions to this equation.
Is this a whole lesson on how to find on your calculator?
Yes. Okay?
Oh my God.
So, we're going to be sketching and then using the calculator to find the exact points. Okay? All right. This is a real big overall, it's a big connection lesson that you need to get so that you can understand the algebraic portion a little bit later, because most everything we do in this chapter is going to be solving for x in some way, shape, or form. And to understand that everything's doing the same thing just in a different way will really help you. Yes, Dylan.
Will we use cosine, tangent, and whatever other one?
Next year.
Why do we use that in geometry? I don't even know what that was for.
When you were finding angles of right triangles and stuff, it's probably the way you used it.
You
probably will not use it again until you hit the unit circle in pre-cal, where you're deriving the unit circle and getting into radians. And
Yeah, I don't know.
okay, you don't have to know just yet. That's okay. All right, so let me talk you through something before we do it. I want you to think about something for just a minute. By the way, we call these x-intercepts.
Zero.
Yes. That is the grown-up word
If it
for
asks
it.
for zeros, we don't have to find the y, right? We can set x equals this.
If it asks for the zeros, you're only finding, and you see how this is really, what was that? If it asks for zeros, you are finding the x-intercepts, okay? And so to do this, we make sure the equation equals 0, and then we find where it crosses the x-axis, all right? Now, let me run you through a couple of scenarios first before we jump into doing it. I just drew a parabola on that graph, and I circled 2 zeros, and we said those are the 2 answers, right? Is it possible for a quadratic to have anything other than 2 solutions?
Yeah. No. Maybe somebody call something else. The ones that go like this and all that.
Is it, so let me ask it a different way. Is it possible for a parabola to cross a different number of times than 2?
No. Not that.
0 times. How might it cross 0 times?
If it's like,
Oh, if the maximum.
it's above
Yeah.
x-axis.
But then it still crosses.
It never crosses the x-axis. I'm only talking about zeros. So this has no zeros. So right now I know I could have 2 zeros, right? 2 zeros is my basic one. That's the one that just this or this, any basic parabola at some point, right?
What if it's vertex on the X?
Ooh, that was the next thing I was going to ask you. If its vertex is on the x-axis,
Then that just means that the vertex on the X-axis.
how many x-intercepts does that graph have? One. So it has 1, 0. So I've got 3 scenarios, okay? I might get 2 answers, I might get 1 answer, and I might get no answers. Okay, do you see why graphically that is? Okay, then let's get into solving some.
Okay.
Okay. Zeros are also sometimes called roots. Some of your calculators might say roots. All right, here's what I want you to do. I want you to look at this, and I'm going to pull that same one that I did first. Find the zeros of the function. Find the zeros of the function. By the way, as you're getting this on your calculator, when you plug in a 0 value, okay, when you plug a value back into the equation, what should you get out?
When you do what now?
If algebraically you found the zeros,
Uh-huh.
if you plug that value back in the equation, what should you get? Okay. You're solving this. You're pretending. What was the equation again? Minus x. Oh, Stacy. You'll want to do a zoom 6 to start with to kind of see.
How do I do that?
Zoom 6.
Oh, the big one.
Yeah. I literally said, you'll want to do a zoom 6 on this graph so you can see it well. And you said, how do I do that? Zoom 6. Oh, okay, thanks. Yeah. All right. Now.
That's a negative.
No.
There's a little left.
All right, so Luke says that's a -2 on the left. He went second trace. I'm choosing 0, left bound, and a good thing we've practiced with this, right? Left bound, right bound, enter, and that is, he is correct, that's -2. So find the other. Cawthon says 3.
Mr. Dot. There you go.
How might I check these?
Plug it in.
What should I get when I plug it in? 0.
I would.
The solutions of these, remember what really I'm doing is I'm saying, when will this equation equal 0? And you're saying this equation will equal 0 when x equals -2 or when x equals 3.
Should you not have drawn?
That's what the solution
But
means.
should you have not drawn the line intercept dot? Line intercept?
It doesn't matter because right now I'm only looking for zeros. Because I'm looking for when
I
does
was saying
this
like to draw it
equation,
accurately.
that's fine. When does this equation equal 0? This equation equals 0 if x equals 2 or if x equals 3. -2. So if you plug -2 in here, watch what happens. -2 squared is 4, plus 2 minus 6 would be 6 minus 6, which is 0.
I'm calculating option, that 4 out is a negative.
That's because you put it in wrong.
Yeah, you got to put it in parentheses when you do that. Okay, same thing if I plugged in 3, even though it doesn't look like it will do it. Robert, 3 squared minus 3 minus 6, which would be 9 minus 3 minus 6, which would be 6 minus 6, which is 0. Both of those x values will give you 0 in the equation. Almost.
You have some updates available?
All right. Let me give you one more. Okay, and this one I'm going to mix it up a little bit, all right?
Okay. I got so many plots. I'm not doing anything. You know how
Solve by graphing.
Let me just put that in our calculator.
Ooh, do you? I don't know.
No, you gotta put it in,
I have no idea.
So we just find zero?
It's gonna be zero either
No,
way.
I'm talking about the first one.
Look, what do you do? Yeah, the first one. First one.
Don't tell us.
Right?
Why, Robert?
Because you have to have it.
That keep going. You're right.
8x 2. No, you have to have it. Wait. Yes.
It's zero equals X.
I need it to equal 0
Oh,
because
yeah. That's the f of x.
I need it to equal 0 because otherwise I can't solve by finding the zeros if it doesn't equal 0 to start with.
Okay,
Zero equals X
Yeah,
squared
facts.
minus 6X
so y
plus
equals
9.
here.
It's 0 equals x squared.
It has 1 0. Yes, Alex.
All right, so several of you have already said it has just 1 0. So let's look at it. It was x squared, what was it? Minus 6x plus 9. Now, as you calculate these, and listen carefully, if the vertex sits on the axis, you're not going to be able to go calculate 0. You're
You do
probably
minimum.
going to have to do calculate minimum for that one.
So what do you do? Same thing.
Second grade.
Okay, yours went down because you moved everything to the other side, and that's okay. Your answer's still going to be the same.
I
So
got,
what you just plugged in?
I got
What you
3.
gave us?
It's 3.
But so what
Okay.
you do to get 0?
I moved everything to the same side.
No, it's not.
No, it's
How, how is that negative 3?
Why is like
Negative
3.00000? You're calculating
It's-
that.
All right.
We have to hit like second and then trace to calculate it? Yeah.
Yes.
Why is that
Because
exactly?
on the last one, mine's
Yeah,
giving
it
me
is.
negative 1.5.
It's
So
like
negative 2.
3.0000. That's your bad.
We'll have to look at it because that shouldn't be right. All right. Shh, 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 shh. Y'all stay with me, okay? This one we had to calculate by doing the minimum because it never, your calculator, the way it finds zeros is it doesn't find 0. It finds where it changes from positive to negative or negative to positive. This one never goes negative, so it can't find a sign change there. So instead we're going to calculate minimum. We're going to go left bound, and then we're going to go right bound, and we're going to hit enter, and we get 3.
What's the difference in this and what we already done? 'Cause, like, I feel like I already knew
We have solved some, we have found intercepts graphically, we have. We just haven't made the connection about it being the
that. But what about it being
solutions.
like completely accurate? Because I can get the answers off my calculator without even writing
It's
it
not
down.
giving me the right answer. Give me 3.98.
I still want you to sketch it, and you'll see why soon. Make sure your equation is input correctly. X squared minus 6x plus 9.
Hey, if I
I
make
have
this bottle
negative
with
x squared plus 6x minus 5.
I'm gonna go out on a limb and say it's whatever kind of app y'all are using on here that is not accurate. I would,
Exactly.
Okay.
3.0.
you got what?
3.0.
It's 3 point.
I
No,
got
that's not it.
3.98. I got 3.00. So,
I got 3.
Record this. It'll say solve for x. This just says solve for x graphically. So you make it equal 0, and then we calculate it. So you'll need to show this, you'll need to show a sketch, and then you'll say x equals 3. That is the solution.
Okay.
and
Okay.
then we can say x equals.
Yeah, just show both. X
Why didn't
equals
they
this
put
and
this
x
in the
equals
other
this.
lesson? Because we literally
All right.
could have done this with.
I know. That's the good thing about it, though, is that you've got some background on it.
Yeah.
All right, listen to this question very carefully. Use a quadratic equation to find 2 real numbers
2 real numbers.
It's
And
what it is.
here.
Can you explain
with a sum of 15 and a product of 63.
Read it again.
These 2 numbers must have a sum of 15 and they must have a product. And here's the thing. When you do this, because I'm talking about using a quadratic and I'm going to solve it, I'm talking 1 variable, not 2. So you have to write them in terms of the other. Okay? So be careful. Do you?
Okay, but wait, repeat what you just said.
Okay, so these 2 numbers, I'm going to solve them using a quadratic equation, which means I'm going to make it equal 0, and then I'm going to graph it and find where it crosses. So I can only have 1 variable.
Oh, I know what it is.
Several of you say that you have it.
No.
2 guys up here said they knew.
I don't know.
I am not able to.
No, I don't want the answers. I want the quadratic equation.
Oh, who cares about the quadratic?
Okay, Luke, when you said I got it, you were talking about the 2 numbers? Oh my gosh.
I don't know.
Okay, so can we agree that one of the numbers needs to be x? Okay.
Well, you're.
So if one of them is x, how can I write the second one using an x and using the information given here? Huh?
Well, you see, there isn't a perfect square for that.
No, y'all, what?
I don't know.
Stop. First line.
Can we just go through it?
Okay. How can you write that they add to 15
Okay.
Plus
eight-
15.
without using another variable? Well, it's not plus 15 because that wouldn't mean if you let one of them be x plus 15. Okay, so if x plus some other number
Oh,
equals
63x
15,
equals 15.
how can I write it in terms of this other
63x
number?
equals 15.
Thank you. 15 minus x.
Okay. I don't know how, but all right.
If they add to 15 together and I can only have one variable, then if I subtract out the first one from 15, what's left is the second one, right?
What adds to 15?
That's what I told you to start with. These 2 numbers must add to 15.
What 2 numbers? No, 63. What 2 numbers?
Small
So
brain
63
equals.
adds
Small brain.
It's like 9 point something and 6 point something.
The 2 numbers, correct.
Okay. So x squared adds 9 and 7.
So look,
No. What's 9 plus 7?
listen, look. Does x plus 15 minus x add to give you 15?
What? Oh, yes.
Yes, it does. X minus x is 0, and it gives you 15. So these 2 things add to give you 15. But multiplied together, they should give you what?
I think that's supposed to be 36.
So x times x, 15, minus x should give you 63.
So how are we supposed to get there? I don't know what just happened.
Yo, how many,
I
like,
think it's
I'm-
36 and not 63.
The-
I'm gonna try.
How many people in this room who understands this?
Okay,
I understand it.
listen.
Like, I know it's.
Thank you.
Listen. What's in green is what's given to you, okay? You have 2 numbers. Your job is to find those 2 numbers by setting up an equation. Those 2 numbers should add to 15 and multiply to 63.
Oh, wait. So when you distribute, it's 15x minus
X squared,
equals 63.
correct. And that will be my quadratic equation.
There you go. Right there.
Okay, I haven't solved anything yet because we haven't gotten to that point yet. All right, if I distribute this through, Goldie is absolutely right. I get 15x minus x squared equals 63.
Can you just tell me how you got 15 minus 7?
Yeah, that's what I'm confused.
Okay, because I need to write it as the sum of 2. I can't just use 2 different variables. All right, I don't want to say, okay, x plus y equals 15. But if you did, let's say you did. Let's say I put my 2 numbers as x and y, right? Because, Robert, this is why you don't understand. Lily ain't even in here. All right, look. Let's do it this way. These 2 numbers add to 15. Something plus something equals 15. Does that make more
That
sense?
makes a lot more sense.
Okay.
Are we looking back?
Yes.
They multiply to 63.
Yes. So X, Y.
So x, y equals 63. I can only have one variable. Think system of equations. Okay? How can I write How can I replace this with something with only x's? Solve this one for y. Subtract x.
See, that makes a lot more sense.
Put it here.
That makes so much more sense.
Okay, let me take this picture.
Yeah. I'm just gonna write it down, actually.
Maybe
If you have an iPhone 11, it was not.
I do. I have an option.
Grant's hand just literally went up. Can you just move?
So now, yeah. So now what I have is 15x minus x squared equals 63. And if I get everybody on the same side, I have x squared minus 15x plus 63. And at this point, I can graph it and find where it crosses the x-axis to find the solutions. And guess what happens?
There's no real zero.
There's no zeros.
There are no two numbers. There's no real zeros. They've graphed this.
Because
Get
there's
something that
no
looks like
solution.
this.
No.
And you go, uh-oh.
It's on the other side.
Would it be
It's up there.
It's top right.
negative x squared? Yeah, negative x squared and positive.
There's
Yeah.
no
Okay,
real
wait.
solution.
It's
There is no real solution.
negative
There
x-
are not two numbers.
Negative x squared and positive, they just mean.
What?
Positive.
I moved everything to the other side.
Oh, okay.
It's a.
This or
That's what I do.
this would give you the same solutions. It doesn't matter what side you move it to.
Hey,
No. Because you said,
I solved it for y. I subtracted the x from both sides.
you said if A was positive or negative, that determines which way it goes up and down.
Correct.
But the
So-
solution will still be the same, right?
Solution's still the same.
Because it'll still get.
You still set it equal to 0. Right. The one we did earlier, it had solutions of like -2 and 3, right? And it looked like this. If you had moved everything to the other side, the solutions would remain the same, but it would be going down.
But that would be the wrong answer.
No, the answer is where it crosses the x-axis. I'm not looking at which way your graph is going. Your answers, the whole point in it is finding out the values of x that make the equation equal to 0.
So it doesn't matter which way it's facing as long as
Correct.
the solution.
But what about on this question if they asked us if it has a maximum or a minimum? Because.
They will not on this question. Not when you're solving this way. Solving takes on a whole other, it's a whole other ballgame,
Okay.
okay?
Well, let's get on that homework
Wait,
then.
so what do we put for x?
So for this one, there is no solution. So think about it. Sometimes that happens, right? When we solve linear equations, sometimes you'd be solving, you'd have things on both sides, and you get down to something like 2 = 5, and you go, uh-oh, there is no solution. There's not any value of x that you could plug in that would ever make that equation true, and the same happens with quadratics. We'll get into imaginary solutions and why that is, but for right now, there is no solution.
I like what you
Look, you skipped this stuff
How is
before.
it no solution?
Because it doesn't cross the x-axis.
Oh, that makes
To be a solution, it has to cross the x-axis. You have 3 scenarios. It can cross once, twice, or none. Twice would be 2 solutions. Once would be 1 solution, and doesn't cross at all would be no solution. And that's perfectly acceptable. And the reason is and when we get a little further in the quadratic formula and everything else, you'll see that it does have solutions, but they're imaginary. And we're talking about real solutions right now.
Let's go to that.
What's our homework?
All right.
What is that?